let us continue the problems based on the national convention. So in the previous video, you have already taken that national convention. That means converting. So what is the radian measure? Whenever they given a degree measure, we have to convert degree measure to radian measure. How to convert degree measure to radian measure? Radian measure is equal, so multiply by pi by 180. Similarly, if they given radian measure, we need to get the degree measure. So what we have to multiply? 180 divided by 5. These are the very important two formula. To get the radian measure, whenever degree measure is given, multiply by pi by 180. We need a degree measure. Whenever they given a radian measure, multiply by 180 by 5. We will get the required degree measure and the radian measure. Now this two formulas are very important. Based on this formula, you may get a 1 marks questions in examination. Okay. Now here, find the degree measure of the corresponding to each of the following radian measures. They are given a radian measures here. We need to find the degree measures. So here radian is that. Always radian measure means pi where. Okay. Here pi is that. Radian symbol is given. Small c they have written. Okay. This is the radian measure is that. We need to find the degree measure. So degree measure is equal to, what is that? Radian measure into, what is the value? 180 divided by 5. We can simply remember that. Here radian measure is that. In a degree measure, the pi has to eliminate. When it is eliminated, it should be present in the denominator. We can get the one hint. So just remember, you might get the confusion. Then we have to multiply pi by 180 or 180 by pi. So just remember one value and respectively with other value easily comes. Or else radian measure means pi is always there. So just eliminate the pi. How do you eliminate the pi? Divided by pi like that. So 180 by pi. Now simplifying, we'll get the required degree measure. Pi get cancelled. So here what we can write? 4 3s are 12. 4 40 pies are, and again 3 1s are 3 15s are 7 into 15. What is the 15 into 7? That is our required value. 7 into 15. So this is the required 7 into 15 is 105 degree. This is the required degree measure of the given radian measure is 7 pi by 12. Similarly, second one, 5 pi by 3. We have to get the degree measure of this one. What is the degree measure of this one? 5 pi by 3 into what we have to multiply? 180 divided by 5. So pi get cancelled. 3 1s are 3 16s are. So pi into 60. Pi into 60 is 300. So the required degree measure of pi by 3 is 300. We can observe that pi by 3 into pi. Pi by 3 also can be written as pi into pi by 3. Already you know that standard angle pi by 3 is nothing but 60 degrees. 60 into pi. So directly we will get it as a 300. Okay, next one. Similarly, third one. So what is the third one? Means suppose they used to do that 6 radian. They used to do the 6 radian. Convert this 6 radian into degree measure. Already you know that 1 radian is equal to how much degree? 57 degree, 12 minutes and 21 seconds. 1 radian is equal to how many degrees? 57 degrees, 12 minutes and the 21 seconds is that. Now here 6 radian is that. Pi is not that. So we have to convert this 6 radian into degree measure. 1 radian is equal to 57 degrees and 6 radian is equal to how many? So what we have to get? This is the degree measure is equal to 6 radian is that into what we have to multiply? 180 divided by 180 divided by simplify. So how do you simplify? Eliminate the pi. How do you eliminate the pi? That means replace the pi. Pi 6 into 180. Pi can be written as 22 divided by 7. That divided by 7 can I take it to the numerator? Pi value is 22 by 7. We have already known that pi is equal to 22 by 7. So 22 divided by 7 taken to the numerator, laws of indices. Now, so 6 into 180 into 7 divided by 22. What is that? 6 into 180 into 7 is 7560. Now, divided 7560 divided by 22. 343.6363 it will come. So 343.6363. Now it is in terms of, it is a degree there. But point is that how will you do this one? Means I just keep it as 343 degree. 343 degree. Okay. So here 0.6363 is that. This we have to convert. It is a degrees that we have to convert into a minute. Minute. How do you convert into a minute? Into 60. If you want to get it as a minute, mean into 60. So 0.6363 into 60. What will get? This is 38.178. 38.178. This is degree to minute is converted. So that I just write it as a 38 minute. It is 38 minute. Again 0.178 minute is that. Minute to second we have to convert. So that into 60. In this case we will get it as a second. What is that? 10.68. This is 10.68. Approximately we can write it as a L1. I just write it as only the 10 seconds. This is all. So in the previous video you might have a confusion that 1 radian is equal to how much? 57 degree, 12 minutes and 21 seconds. How it comes? I got the point. Here is the clarification. What is that? So 25 value you have to replace as a 22 by 7 multiply divided by 22, 7560 divided by 22. That will get a 343.6363 like that. It is a degree here. So 343 degree. Point is that. That means this 0.6363 minute is that converts. Degree is that convert into a minute, because 1 degree is divided into a 60 minute. 1 degree is divided into a 60 equal part. Each part is said to be a 1 minute. So that is the reason I just converted it as a 1 minute. 0.6363 degree is converted into a 38 minute. How it converts? Multiply this decimal value multiplied by 60. For this decimal value, if you multiply by 60, 38.178. This is in terms of minute. So 38 minute. Again decimal value 0.178. It is in the minute. Convert into second. How do you convert into a second? Multiplied by 60. That will get a 10.68. So here this is the required degree measure of the 6 radian. 6 radian is equal to how many degrees? 343 degree, 38 minutes and 10 seconds. Now let's move to the next problem. Yes, fourth one is 2 radian. Convert into degree measure. So degree measure is equal to 2 into 180 divided by pi. Pi can be replaced as 22 divided by 7. Divided by 7 taken to the numerator. So what will get? 2 into 180 into 7 divided by 22. This divided by 22 as this. Multiply. 2 into 180 into 7 is 2520. Done. This 2520 divided by 22 is 114.5454. It is in terms of degree. Convert. This is 0.5454 degree is that. This degree to minute. How to convert? Multiplied by 60. This we can write 114 degree. 0.5454 degree can be converted into a minute. So for this decimal multiplied by 60. What is the answer? Is 32.724. So that means 32 degree. Next again 0.724 minute is in terms of minute. Convert into second. How to convert into second? Multiply by 60. What will get is 43.44. That means 43 seconds. This is minute and it is a second. Now the 2 radian is equal to how much? 114 degree, 32 minutes and 43 seconds. Now the next one is, what is the next one? Fifth one is 11 by 16 radian is that. 11 by 16 radian convert into a degree. How do you convert into a degree? Degree major is equal to radian major into 180 divided by pi. Replace the pi. L1 into 180 divided by 16 into 22 divided by 7 taken to the numerator. What will get? This is value. L1 into 7, 77. 77 into 180. 77 into 180 is 13860 divided by 16 into 22 is 52. Now 13860 divided by 352 is 39.375. It is in terms of degree. Converting to the decimal value, converting into minute. What is that? 0.375. It is in terms of degree. Converting into minute. What will get? 0.375 into 60 is 22.5. Now here we can write 22 is a minute. 0.5 into 60. It is in terms of minute. Converting to second. 0.5 into 60. That is nothing but 30 seconds. So this is the 30 seconds. Okay. So 11 by 16 radian is equal to how many degrees? 39 degrees, 22 minutes and the 30 seconds. So very important type of the problem for the 1 marks session. They used to ask that for the following degree measure convert into radian measure. Now reverse. They used to do the radian measure and the degree measure. So let's move to that type of the problem. Yes. Convert degree measure to radian measure. They have given a degree measure. We have to get the radian measure. Degree measure. First one is 15 degree. So we need to get the radian measure. So radian measure is equal. What is that? Degree measure into pi divided by 180. Simplify, we will get the answer. So what is the answer? 15 ones are okay. 15 ones are 15 and 15 twos are. Is that clear? Sorry, 15. Okay. So this will get pi divided by 12 radian. So 15 degree can be written as pi by 12 radian. Are you clear? Very simple. Degree measure is given. Degree measure is given. We have to get the radian measure. So that for the given degree measure multiplied by pi by 180 and simplify. That's all. Whenever writing the radian measure, keep the pi. And whenever writing the degree measure, you have to replace this pi as a 22 by 7. In this case, it is not necessary. Okay. Next one is 25 degree. What is that? Radian measure is equal to 25 degree into radian measure we have to convert. So that multiplied by pi by 180. What is the answer? 5 pi is 25. 5 36. So this we can write pi by 36. So okay. 5 pi by 36 radian. Again it is not possible to simplify. Next, third one is 240 degree. 240 degree we have to convert into radian measure. So 240 degree into pi divided by 180. What will get? 1 of the 0 get cancelled. So here 6 3s are and 6 4s are, and we can write it as a 4 pi by 3. 4 pi by 3 is a radian measure of the 240 degree, or else we can write pi by 3. What is the pi by 3? Pi by 3 is nothing but, in terms of degree measure, is 60 degree. 60 into 40. 60 into 40 is 240 degree. Okay. Now next one is fourth one. 40 degree 20 minutes. Here directly they have one integer as a degree measure, but here it is integer in terms of degree, as well as the minute is also there. Now first of all, previously just converted radian measure to degree measure in terms of degree, minute and the second. Here degree and the minute, second they are not given, only degree and the minute they are given. First we need to convert purely this value in terms of the degree. How do you convert in terms of degree? Is nothing but 40 degree plus 20 seconds is that. This is second, we have to convert into a degree. How do you convert into a degree? Multiply by 60 or divided by 60. In this case, it is divided by 60. Now, it is purely converted into degree. Are you clear? Okay. Now, 2, 3. So that will get 40 plus 1 divided by 3 degree. What is 40 plus 1 by 3? 40 plus 1 by 3 is nothing but 0.3. 3 will get. So this is nothing but 40.33. 40.33 is purely in terms of degree we have converted. Now this is simplified. We have to get the radian measure. So 40.33 into 5 divided by 180. So what is the required radian measure? 40.33 divided by 180 into 5 is that. So just simplify. 40.33 divided by 180 is 0.2207, as I said, 0.227 into 5. This is in terms of radian. Okay. So this is how we have to convert degree measure to radian measure to degree measure. Very important type of the problem. Now let's move to the next type of the problem by using the theorem number 1. What we have studied in a first day was theorem number 1. Let r be the radius of the theta, radius of the circle. Theta is the, in terms of radian, it is the central angle. Then L is the arc length. Then relation between radius of the circle, central angle, and arc length is L is equal to r theta. Based on this result, let's have a problem. Yes. Third problem. Find the radius of the circle in which a central angle of 60 degree intersects an arc of length 37.4 centimeter. Use pi value as 22 by 7. Okay. What we need to find? Find the radius of the circle. Okay. Suppose the circle is that. This is the circle. For this circle, we have to find the radius is equal to how much? To find the radius of the circle, what they have given? Okay. What they have given? In which a central angle of 60 degree intercept. 60 degree is intercept. How it is intercepting 60 degree? An arc of length is 37.4 centimeter. Okay. At the center of the circle, the 60 degree angle is subtending, and arc of length, they have given arc length. What is the arc length is given? Arc length is 37.4 centimeter. 37.4 centimeter. Arc length is there at the centrally. 60 degrees angle is subtending. In that case, what is the radius of the circle? I think question is very clear. We need to find the radius of the circle. To find the radius of the circle, central angle is 60 degree. Arc length is 37.4 centimeter. That means, first of all, write the given data. What is the given thing? They are given arc length. What is the arc length is given? 37.4 centimeter. And central angle theta is given. Theta is equal to how much? 60 degree. And one more thing, you just remember, already know that our formula L is equal to r theta. Here three values are there. One is arc length, radius of the circle, theta is the central angle. Here a condition is there for the theta. Theta must be in terms of the radian. Are you sure? Theta must be in terms of the radian. Just go back to the theorem number 1 statement. I think you have already noted down that theorem in your notebook. So that just see the theta. Theta must be in terms of radian. But they are given in terms of degree, 60 degree. Convert into radian. That's all. 60 degree can be converted into radian measure. What is the radian measure? Theta radian is equal. 60 degree is nothing but pi divided by 3. Or else 60 into pi by 180 will get the required radian measure. Okay, theta is given. Now what is unknown value? We have to find the radius of the circle. So L and the theta are known. Only unknown value is r. You can easily get it. So better write the formula in the solution. We know that L is equal to r theta. We need the radius. So radius is equal to L divided by theta. So r is equal to L is 37.4. Theta is pi divided by 30. Pi by 3. Simplify. 37.4 divided by 3. I just taken to the numerator and divided by pi is left. Again, they are given. Use the pi value as 22 by 7. So r is equal to 37.4 into 3 into or else 22 divided by 7. I just taken to the numerator. So what is the r value? Divided by 22 as it is multiplied. 37.4 into 3 into 7. What we get is 785.4. Now 785.4 divided by 22 is 35.7. Therefore required radius is 35.7 centimeters. Required radius of the circle is 35.7 centimeter. This type of problems are also very important for the 2 marks or the 3 marks session. In the same manner, let's take the next problem. Yes, fourth one. In a circle of diameter 40 centimeter, the length of the chord is 20 centimeter. Find the length of minor arc of the chord. Okay. In a circle, okay, consider a circle. Roughly, I just take one diagram. If you draw the diagram, you will get a clear picture of the what is the given problem. Okay. In a circle of diameter, already know that diameter. What is the diameter? A line segment which is passes through the center of the circle and whose end points are lie on the circle. Suppose if I name this as a AB. AB is the diameter of the circle. Diameter, already know. A line segment which is passes through the center of the circle and whose end points lie on the circle. It is the largest chord of the circle. In the circle, chords are there, so it is largest chord of the circle. Anyway, diameter length is given. That means AB length is given. What is the AB length? AB length is how much? 40 centimeter. Total diameter length is given. So that I just name it as a big diameter. And apart from that, what they are given next? The length of the chord is 20 centimeter. One chord is that. Suppose the length of the chord if you take it. Okay, they are given a chord. Suppose the chord is like this. BC is the chord they are given. Find the length of the chord. Chord is nothing but one line segment inside the circle. BC is given. How much it is? 20 centimeter is that. Chord length is BC. Chord is given. How much it is? 20 centimeter. And find the length of the minor arc of the chord. Minor arc of the chord. Now we need to find the arc length. What we need to find? Arc length is nothing but L value we are required to find. So once again, clearly observe that what is the given problem. In a circle, the diameter of the circle is 40 centimeter. The length of the chord is, one chord is that in circle, that length is 20 centimeter. Then find the length of the minor arc of the chord. Here, two arcs are there. What are the two arcs? One arc length is BC. Only this much. One arc length is BC. This is one arc length. Another arc length is that. What is the another arc length? The another arc length is BE BAC. This is the another arc length. Whether we need to find the BAC arc length or only the BC arc length. They particularly mentioned that length of the minor arc. Minor is nothing but smaller arc length. Smaller arc length is nothing but BC arc length we need to find. That is L is equal to L equal to find. Okay. To find the arc length, what we have to get? So we know the formula L is equal to R theta. So L we are required to find. Do you know the radius of the circle? Do you know the radius of the circle? Directly they are not given radius of the circle. They are given a diameter. With the help of the diameter, we can easily get the radius. Okay, one value important. Then is they given a theta angle, central angle? Have they given? They are not given, but we'll get it. The angle. How to get the angle? Angle we can get it. So BC is the chord is that. Now I just join that. This one. Our center of the circle is OC. I just join. If I join the OC, what will get? First of all, radius. Radius is equal to diameter divided by 2. 40 divided by 2. That is nothing but 20 centimeter. Radius is 20 centimeter. The chord is also 20 centimeter. What about this one? This is also the 20 centimeter. Then what will be the theta? So here, observe that one triangle is there inside the circle. All the sides of a triangle are equal. This side length is 20 centimeter, 20 centimeter, 20 centimeter. That means equilateral triangle. In an equilateral triangle, what is the interior angle? Interior angle is equal to the 60 degree. I think you have already know the condition. So, in an equilateral triangle, interior angle, each angle is equal to 60 degree. In that case, what is the central angle? Central angle is becomes a 60 degree. 60 degree is nothing but we just get the theta in terms of radian is pi by 3. 60 degree instead of writing in terms of degree, I am just going to write in terms of radian because in this formula we need a theta in terms of radian. So that reason I just written theta as pi by 3 radian. Okay. Radius is chord, theta is chord. Now we can easily get the arc length. So I just mentioned that. Let L is the arc length. L is the minor arc length. The minor arc length. Okay, now we know the formula. What is the formula? L is equal to r theta. We have analyzed this problem. Now L is equal to, what is the radius? Radius is 20 centimeter into theta is pi by 3. And make sure that theta must be in terms of radian. Okay. In this problem, they are not given pi value. Use pi value as 22 by 7 or 3.141 like that. They are not given, but we have to use it. You must remember that value. So 20 into pi value is 22 divided by 7 into 3 as it is. Okay. So 20 into 22. 3 into 7, 21. So 20 into 22. What is the value of 20 into 22 is 440. 440 divided by 21 is 20.95. Therefore, the arc length is, the smaller arc length is how much? 20.95 centimeters. This is the required arc length of the given problem. Circle having diameter 40 centimeter and it has the one of the chord length as a 20 centimeter. In that case, the minor arc length is 20.95. Okay. Now the next problem is next one. In two circles, arcs of the same length subtend angles 60 degree and 75 degree at the center of the circle. Find the ratio of their radii. Ratio of their radii. Radius singular sense, radii plural sense. Okay. There are two circles are there. Okay. This is one circle. This is another circle. I just name this circle 1, C1. This circle second one as a C. There are two circles are there. Two circle whether two circles are there. I just radius of the circle one is r1, radius of the circle 2 is r2. In a two circles, arcs of the same length, arc length is same. Arc length is same means suppose the arc length L1 is the arc length of the first circle. Whatever the arc length is there in a circle 1, the same arc length is there in a circle 2. For example, suppose the arc length is 10 centimeter in the first circle, the same arc length is there in the second circle. Are you sure? Arc length of the first circle is same as the arc length of the second circle. In such case, I just take the L is the arc length of the first circle as well as the same arc length is the L is the arc length of the second circle. Okay, in that case, arc length. In a first circle, how much angle is subtend? Arc of the same length subtend and angles 60 degree. It is a 60 degrees there. In a second circle, it is subtends and 75 degree. You might have a confusion or doubt. What is the confusion? Here, arc length is same, then how the angles are different? Yes, obviously it will be different. It depends on the radius of the circle, because radius here smaller radius is there, here larger radius is there. Obviously, if the radius is varying, then the angle is also varies. Are you sure? For example, suppose you take the larger circle. In that larger circle, small arc length 10 centimeter, only the small angle, very small angle will get it. So whenever the radius is increasing, the arc length is decreasing. So that varying the radius and the arc length is also varies. So that reason here difference is that R1 angles. Okay. Next one. What we need to find? Present. Find the ratio of their radian. What is the ratio of their radian? In which ratio the radius or radii of the circle is there? Okay. Now I just consider let, or first of all given. What is the given data? So let or else theta 1, I just call it as a theta 1, this is the theta 2. Theta 1 is equal to 60 degree, theta 2 is equal to 75 degree. And apart from that, so that now let L be the arc length of the circle. Arc length of the circle. L is the arc length. L is the arc length of the circles. Both have the same arc length, so that in both the circle arc length is L. L is the arc length of the circle. Now theta, and we know that formula L is equal to r cap. Using this one, we have to find the ratio of their radii. So for finding the ratio of their radii, here theta must be in terms of radian. Converting to radian. What is the radian measure of 60 degree? 60 degree radian measure is pi by 3. And 75 degree radian measure. I just do the rough work. 75 degrees are converting to radian. That is pi divided by 180. Simplify, what will get? So 75 degree measure is that converting to radian measure. So this is the 5 pi by 12. 75 degree in terms of radian is 5 pi by 12. I just did the rough work and directly did it. Or else solve here, no problem. 5 pi by 12 is the radian measure of the 75 degree. Now we know that the formula L is equal to r theta. So here I just write L1 is equal to, or L is same for the first circle. For the first circle. For the first circle, what is the formula? L is equal to radius is r1, the central angle is theta 1. For the second circle, what is that? L is equal to r2 into theta 2. Here observe that L and L both have the same arc length. Can I equate these two values? Yes, because this is equation number 1, this is equation number 2. LHS side is same, arc length. Whatever the arc length is there in the first circle, the same arc length is there for the second circle. equating the equation number 1 and 2. What we get? R1 theta 1 is equal to R2 theta 2. Simplifying, what we get? R1 divided by R2 cross multiply. Theta 1 divided by theta 2. So is equal to theta 1 value. What is the theta 1 value? Pi divided by 3. Whole thing divided by theta 2. What is the theta 2? Pi by 12 is the simplify using the laws of indices, whatever. Pi by 3 into. So I just write pi divided by 12. I just take into the numerator. Now here pi get cancelled. 3 ones are 3 fours are 12. So that left hand side R1 by R2 is equal to how much? 4 divided by 5. Therefore, we can write the conclusion. What is the conclusion? R1 by R2 is equal to how much? 4 by 5. So the ratio is required. Find the ratio of their radii. Ratio of their radii is this part. Therefore, the required ratio of radii is R1 is to R2 is equal to 4 is to 5. What is the meaning of this one? Suppose the first circle has the 4 cm as the radius, the second circle will be 5 cm. Suppose the first circle has the 40 cm as the radius, then the second circle will be 50 cm of radius. So this is how the meaning of the question, and required answer is, or required ratio of the radii is 4 is to 5. Okay, hence the solution. Now I just stop this problem with this problem. The remaining problems will be discussed in the next video. After this problem, whatever the problems are there in your textbook, just better to solve it. So just maintain in a particular notebook and solve all the problems. So, and apart from this, one more thing. As your NCERT book, the whatever they have mentioned, the serially, for your understanding purpose, we are not following the NCERT method. So I am just following some topics as is beginning topics. I am going to explain at the end of the trigonometric chapter. So that better to convince that one. So that schedule will be, I will post in the WhatsApp group. That whatever the schedule I am just going to follow in this trigonometric function chapter. The serial order I will just mention, or else I will just send in a WhatsApp group. I am just following that manner because of your convenient method or your convenient way. So now I just stop here. We will continue in the next video. Okay, thank you.